And let's put the electronics away, please. And today we're going to talk about how we find angles using trig. All right, so just a couple of reminders. We said that our trig ratios, our trigonometric ratios, sine, cosine, and tangent, work because if we have a right triangle and we know one other angle that's going to be similar to any other right triangle with the same angles, no matter how big or small they are. And we came up with a way to remember what we gave those ratios on these right triangles a special name, sine, cosine, and tangent, and we came up with a way to remember which ones went together. And that was, we wrote it on the board before. Sohcahtoa. This tells us that, and just to recap here, that the sine was the opposite over the hypotenuse. The cosine was the adjacent over the hypotenuse. And the tangent was opposite over the adjacent. So this was our little way of remembering which sides went together to make these ratios. And in our last lesson, we used these ratios. We plugged our angle, sine or cosine or tangent of our angle, into our calculator to help us find the sides of the triangles. But today we're going to use this. We'll know the sides of the triangles, and we want to find the angle. So I'm going to write some steps. Our steps are going to look a lot like the steps that we use to find sides until the end, until what we do with our calculator. So our first step, we always want to label our triangle. And by label the triangle, when we're talking about trigonometry, we're going to label the sides opposite, adjacent, and hypotenuse based on which angle we're looking at. Once we label our triangle, we decide which trig ratio to use. And Sohcahtoa is going to tell us which ratio we want to use, depending on which sides we have. We're going to write our equation, just like before. Our equation is going to be exactly the same. It's either going to be the sine of the angle equals the opposite over hypotenuse, depending on which sides we have. The cosine of the angle equals the adjacent over the hypotenuse, or the tangent of the angle equals the opposite over adjacent. So it's kind of nice when we're finding angles, because once we write this equation, now we can go directly to our calculator. And on our calculator, we are going to use the inverse sine, inverse cosine, or the inverse tangent button to find the angle. So this sine minus 1, cosine minus 1, tangent minus 1 is we call that the inverse sine, the inverse cosine, or the inverse tangent. Rather than telling us the side, it tells us the number. Rather than telling us the ratio, it tells us the angle. So just inverse sine, inverse cosine, inverse tangent tells us an angle. So our steps are exactly the same until the very end. And at the end, depending on which equation we used, we'll use the inverse cosine, inverse sine, or inverse tangent to find our angle. So these problems are really, they turn out to be very easy. So all I want to do is do a couple of examples of finding the angle using the inverse sine, inverse cosine, or inverse tangent method. So to find the angle, we use the inverse sine, inverse cosine, or inverse tangent. So questions on our steps. Really the same process we did before. You just don't have to calculate for the side, you have to calculate for the angle. All right. So let's look at a few examples. So here's our triangle. Oops, I don't want that to be 42 degrees. I want that to be x. We don't know the angle. And our question says, find x. So x is an angle. We need to find the angle. Well, let's follow our steps. So is 13 the opposite, the adjacent, or hypotenuse for this angle? Hypotenuse. The hypotenuse is always the hypotenuse. We never call it that. So this one we're trying to be tricky. So this one is the hypotenuse. How about 7? Opposite or adjacent for angle x? Opposite. It's not next to, it's across the triangle. So that's going to be opposite. So then we say which trig ratio, and let me write it up here just as a reminder. Whoops. Interesting. There we go, Sohcahtoa. So which trig ratio tells us about the opposite and the hypotenuse? What is it? I hear some whispers. What is it? Sine. Sine is opposite over hypotenuse. So I'm going to write my equation. The sine of the angle x equals the opposite over the hypotenuse. 7 over 15. 13. Thank you. And then what we need to do is x equals the inverse sine of 7 over 13. And I'm just going to plug this into my calculator just like this. So here's my calculator. Inverse sine is right here, the shifted button above sine. So inverse sine of 7 divided by 13. Enter. And that tells me that angle is about 32.58 degrees. Now the other way I could do this problem is,
what is the sine of -1 at the top?
So that means inverse. It's undoing the sign. So it gives us the opposite of the inverse of the sign. So rather than the ratio, it gives us the angle. So if we press the sign button tells us this ratio. If we have the ratio, the inverse sign tells us what angle gives us that ratio. So that's what it's doing. So the other thing we could do, the other way we could do this problem is right here we could calculate 7 divided by 13. So let me do that. So 7 divided by 13 is 0.538, and I would keep 4 decimal places here. So 0.5385. So this is about 0.5385. I could also say x equals the inverse sine of this decimal. So I could calculate 7 divided by 13 before I put it in my calculator, and I could put it in my calculator this way. So I could say the inverse sine of my answer there, 0.5385, enter, and I get the same thing. 32.58 degrees. So I can do the problem either way. It's nice to be able to just plug it in the calculator just like we wrote it. And calculate it that way. So our calculators are nicer than the calculators that I had, where we always had to do the So you can just plug it in your calculator just like you write it on your paper. Plug it in just like that. And that tells us our angle. And this comes out to 32.58 degrees also. So I can do it either way. Questions there? All right, let's look at another example. So here's our triangle this time. That. Go. I'm going to call this angle theta. We like to use this Greek letter theta when we're doing trigonometry. So if you see that, don't let it freak you out. It's just a letter, just like x. And I'm going to say this is 8, and this is 12. And we want to find theta. So we're looking for our angle. So let's label our triangle. Is 8, and I forgot to write, this is our 90-degree angle. Is 8 the opposite, the adjacent, or the hypotenuse for this angle? Opposite. How about 12? Adjacent. So which trig ratio tells us about the opposite and the adjacent? Tangent. Tangent is opposite over adjacent. So I write my equation. Tangent theta equals 8 over 12. And what I need to do now is use inverse tangent. Theta equals the inverse tangent of 8 divided by 12. I'm going to go to my calculator, plug that in. Inverse tangent is up here. 8 divided by 12. Enter. And I get 33.69 degrees. And one thing really quickly about using your calculator, notice that I'm putting this 8 divided by 12 in parentheses. So you can't in your calculator this calculator automatically puts the parentheses there. If it doesn't, see, I can't even erase that. So if your calculator doesn't automatically do the parentheses, put it in parentheses, because otherwise you'll calculate the inverse tangent of 8, and then it will divide that number by 12. So make sure when you put this in your calculator this way that you have a parenthesis there. Most calculators do it automatically, most calculators like this, but just in case. So what did we have? Inverse tangent of 8 divided by 12, and we had 33.69. So because we were looking for an angle, we had to use the inverse tangent. We have the tangent of our angle, so to find the angle we use inverse tangent. Questions there? All right, let's look at one last example. And that's really all we're talking about today. So we want to find x here. So let's label our sides. Is 3 for angle x, 3 opposite, adjacent, or a hypotenuse? Adjacent, it's next to the angle. And 19? Hypotenuse. Hypotenuse always across from the 90-degree angle. All right, so which trig ratio tells us about the adjacent and the hypotenuse? Cosine. So I write cosine x equals 3 divided by 19. And because I have the cosine, I'm looking for my angle. I have to use the inverse. X equals inverse cosine of 3 over 19. I calculate that exactly like that in my calculator. Inverse cosine right here. 3 divided by 19. Whoops. And so I made a mistake and my calculator says you can't do that. So let me go back here, turn that into a divide. That looks better. Hit enter, and I get 80.92 degrees. So that's all the homework tonight. All it has to do with is this kind of problem. We want to find the angle. When we need to find the angle, we use the inverse sine, inverse cosine, or inverse tangent, depending on which trig ratio we used, which one we wrote. All right, questions there? Okay. Our homework. Very short.